The first step in this proof is to choose which side of the identity to simplify. Often that choice is easy. Sometimes it isn't. If a side has double angles, half angles, or other forms for which we have identities, then choosing that side is often a good bet. When the sides look equally complex, just choose one and go ahead. If you get stuck, you can always choose the other side and start over. In this example, let's choose the right side to work on. All functions can be expressed in terms of sines and cosines. If your expression contains a function such as tangent, this is often a good way to start the proof. Here we can start by changing the tangent term to its corresponding sine and cosine ratio. The next step in this proof is to recognize that each term contains sine squared x and factor this from each of the terms. A little algebra with common denominators, and then applying the popular Pythagorean identity nearly completes the job. Remember to always be aware of the other side. We need to make both sides look the same. Notice that substituting the tangent function back in for the sine and cosine ratio finishes the proof. We have arrived at our goal. In trigonometry, we frequently must use the rules of factoring learned in algebra. You probably recognize the difference of perfect squares on the left-hand side of this identity. The first thing we notice is that the Pythagorean identity enables us to change the first factor into 1. In the next step, recognize that the other factor is a form of the double angle identity for cosine. We've now arrived at our goal of transforming the left side of the identity into the cosine of 2x. A rather complicated expression has been made much simpler.